I like to start, I always pick out a few good quotes that I feel kind of like sum up some of what I'm trying to do and what I think the great work over the years has been all about. And this is one of them that I find to be literally true over and over and over again as I go through and I learn. And I'm sure you've all read it. It's been up there about the last 5 minutes. But the thing I want to emphasize is the second sentence up there where it says, the remains of this knowledge are everywhere about us in everyday use and perfect. And I find this to be literally true. And part of what I try to do with my programs is to communicate to people this understanding of how these things are manifest in the everyday world in ways that one even doesn't even begin to suspect, but they're there. And beginning to recognize the fact that there is a sacred component to our everyday life can be quite transformative when you realize that when you begin to ponder really how it ended up being there. So the last line there, it says its revival will point to a restoration of the period prior to the confusion of lip. That refers to a kind of a universal tradition, but it's certainly pretty prominent within the Judeo-Christian tradition, which is the idea that there was once a universal language, and this universal language fell into disuse as a result of some kind of a catastrophic event involving the destruction of in the Bible anyway, it's the great Tower of Babel that they're building. And it was appeared to the Lord that humans were going to achieve too much too quick. So actually, if you read the Old Testament account, it's pretty apparent there that they're talking about a plurality of gods, and they get together and they say, let us go down and there confound the tongue of man, otherwise he's going to be able to achieve anything and he's going to become like one of us. If you actually go in and read the words in the King James, you'll find that the reference is plural, and it's quite strikingly remindful of when one reads some of the Sumerian accounts when the Council of the Gods were gathering to determine the fate of mankind. In any case, that's what this is referring to, this idea that there was a universal language. So what is the universal language? It's symbolism. It's number and symbolism and form. And number, symbolism, and form are universal regardless of the spoken tongue, which one happens to have been brought up in. And hopefully in the next hour and a half, I'm going to be showing you examples of this so that you can see for yourself what actually the universal language of geometry and symbolism actually means. So we're going to jump right into it here and talk about sacred numbers embedded in everyday phenomena. These are the things that we all pretty much think about and use on a daily basis without ever really pondering the fact that there's actually deep symbolism hidden within them. We measure our life in terms of days, of 24 hours, referred to as a tropical or solar day. And it turns out that 24 of these hours are 1,440 minutes. This is one of the key numbers within the ancient canon of numerical cosmology that the ancients used to basically design and create their world. The 1,440 minutes equates to 86,400 seconds. So if you just listen to these numbers, look at them, and let them kind of soak into your brain, once you've gotten into this as actually a system, a methodology of transmitting information, these numbers are actually carriers of information because each number stands for meanings beyond just the apparent ones. So we see 1,440 minutes is equal to 86,400 seconds, and a 12-hour span of time, which is usually represented on the clock, 720 minutes, which equals 43,200 seconds. So just look at those numbers. You'll think that obviously 43,200 is half of 86,400. The 1,440, we're going to encounter that number again here momentarily. So these are just examples of some of the time measures, how we think about time in our particular culture. Space measure, we talk about a foot, we talk about of 12 inches, we talk about a square foot. And you'll notice that the square foot has the same repetition of digits, 144, as the 24 hours does. All we do is we tack a 0 on that, and we have the number of minutes in a day. 144 square inches. Now it turns out that if you ever read the book of Revelations, which I highly recommend if you're interested in symbolism and esoterica, the book of Revelations talks about the holy city which was revealed to St. John the Divine in a vision on the mountaintop. And a man with a measuring line reveals to him this vision of the holy city. And the holy city is described as having a wall around it, and the wall is described as being 144 cubits. We'll see the actual quote in a few minutes here. But that number is preserved in the scriptural writings. We have a cubic foot equaling 1728. I want to call your attention to the 1 square yard, which is 1,296 inches. As it turns out, we could stick a 0 on the end of that, and we have 12,960 years, which turns out to be an awesomely important span of time in terms of some of the great cycles that affect this planet, and that's what we're going to be getting to. Geometry, everybody knows that a circumference of a circle is divided into 360 degrees, and that 360 degrees of arc, because each degree is subdivided into minutes of arc, there is then 60 times 360, as it says there, 21,600. And then you'll notice the 21,600 minutes of arc equals 1,296,000 seconds of arc. That's a mighty fine subdivision of a circle that would be used mostly by astronomers to measure the motion of distant stars. But notice that number, 1,296,000, and you'll see that it's the same number, just raised by 3 orders of magnitude as the number of square inches in a square yard. Okay, now another thing you might notice about most of these numbers from 1440 to 8640, 43,200, 144, 1728, 36, 1296 is that they all Kabbalistically add up and reduce to the single digit 9. Notice that all of them. Pick any one of them, other than, say, with the exception of 24, but 1440 adds and reduces to a single digit 9. 1296, you'll notice the same thing. 1 and 2 and 9 and 6 is 18, which adds to a 9. Okay, so if you're taking notes, write these down or make mental notes of these numbers, because these are the numbers we're going to be encountering now as we progress through this journey here into the hidden mathematics. So we will start by looking at how some of these same numbers and other numbers are associated with the measures of geometry. And here we have what I refer to as the alphabet of sacred geometry, and these are the simplest forms. These are the polygons. You have a circle, which is actually not a polygon, but we have an equilateral triangle, a square, and a pentagon. And each of these can be measured by the number of degrees that determine the angles of the sides. So for example, we look at a circle, which is just a special case of an ellipse with eccentricity of 0. We've covered this already, so let's go right to the equilateral triangle, and we'll see it's 60, 60, and 60, which equals 180 degrees. Again, notice that we've got the number 9 recurring. We go to the square, which is 4 times 90 degrees. The total number of degrees defining the square is 360, the same as the circle, the same as the measure of a circle. And we measure the polygons by essentially measuring the angles of the vertices or the corners. So then likewise with the pentagon, each of the angles between successive edges is 108 degrees. So you multiply the 108 times 5 and you get 540. Again, notice, everything adds up to 9 for some strange reason. 108 is going to turn out to be a very important number. It's a lunar number, as you're going to see. 108, anybody know what metal has an atomic weight of silver? Atomic weight of 108? Yes, that's right, it's silver. Very good. All right, so let's get into some of the solids. Tetrahedron is this form right here, and it's composed of 4 of the equilateral triangles. So we have, as it says here, there's 4 triangular faces. 4 times 180 is 720 degrees. That is the total angular measure of this particular geometric form. This is known as one of the Platonic solids, or regular polyhedra. Polyhedra means multiple faces, and the regular polyhedra is the family of 5. There's only 5 that have the same shape or the same polygonal face. In this case, the equilateral triangle. And then we will move on to the cube. And the cube is 6 faces, and they're each square, and we saw that each of those square faces had 360 degrees, 6 times 360. The important thing is to grasp that the total number of degrees in this form is 2,160. 2,160, and we're going to find out that that number actually turns out to be pretty significant in the measure of other parts of time and space. Then we'll go to the octahedron, and it has 8 triangular faces. This is our octahedron right here. And they're all, you'll notice that so far the tetrahedron and the octahedron are both composed of triangular, equilateral triangular faces. And essentially, if you look at the difference between the tetrahedron and the octahedron, you could just imagine it if we could take the tetrahedron and split it along an edge and insert a 4th triangular face, it would cause it to flatten out somewhat, and it would give us the top half of the octahedron. And likewise, we could insert a 5th equilateral triangle in here, and it's going to give us the icosahedron, which I'll show you in a minute. If we tried to insert a 6th one, though, we discovered that the whole thing flattened out into 2 dimensions. So that wouldn't work as far as enclosing space. So in any case, notice we're seeing a recurrence of this number that we saw, 1440. Remember, we saw that number back right here, the number of minutes in a day. So let that relationship sink in. The number of minutes in the time that it takes our Earth to spin exactly once on its axis relative to the sun happens to be the same number of degrees that define the octahedron. And that's actually what we're talking about there when we're talking about a tropical or solar day. We're talking about exactly one rotation of the Earth on its axis relative to the sun. Okay. Then we have the icosahedron, which is 20 faces, all equilateral triangles. You can see if you look at the vertex of this thing, you see that there are 5 faces clustered around each vertex. So if we were to split an edge, insert another triangle, what it would happen is it would flatten out into a hexagon, a flat hexagon, with 6 equilateral triangles about its center. In any case, there are 20 of these triangular faces. 20 times 180 is 3,600. So again, we have one of our 9s. And then our final is our dodecahedron, my favorite shape. This is what Plato referred to the dodecahedron as being the shape of the universe itself. The dodecahedron, you'll notice, has 12 faces, 20 vertices, whereas the icosahedron has 20 faces and 12 vertices. So they're duals of each other. We could actually suspend this icosahedron. If the dodecahedron was hollow, we could put it inside, and we would discover that each corner of the icosahedron coincided with the center of the pentagonal face of the dodecahedron. Okay, each pentagonal face, as we found out, each edge was 108. 5 times 108 is 540. 12 times 540, as it says, is 6,480. So again, we've got the number 9 redundantly occurring over and over again in these measures. Okay, 6,480 turns out to be a critically important number as well, as you're going to see as we proceed along here. Oh, and then we have the star tetrahedron, which would be 2 tetrahedrons interlaced, and I don't have one of those today, but if you can picture a tetrahedron like this and then one like this interlaced, it gives you this, what's known as sometimes the star tetrahedron or the stellated octahedron. It is composed of 2 tetrahedrons, each of 720. So here again now you're seeing the repetition of this same number, 1440, being the measure of the star tetrahedron.